Hello, everyone, and welcome to ZEIT Day San Francisco. I thank you for being here today on this beautiful Saturday in San Francisco. Many of you have come from places very far away. Many of you are tuning in from our live stream on Periscope and YouTube. So thanks a lot again for being here. For those of you that have not heard of us, many of you over the internet, I want to introduce ourselves and introduce our mission that is so important to us. It's this idea of bringing the power of cloud computing to everyone in the world, to make it accessible and easy, sort of like the revolution of mobile computing was compared to the predecessing desktop computing. In addition to that, we care very deeply about building the best developer tools that allow people to get started, that allow people to be more creative, that allow designers to start developing, or developers to try out more ideas, perhaps also become designers. Our mission is enhanced and channeled through our contributions to open source. In fact, we started the company about 2 years ago, and it started with the release of an open source project. It makes me very proud that ever since, in the short amount of time of 2 years, we've grown to become the 50th largest GitHub organization by measure of stars, which means you, the community, are always supporting us and telling us that what we're doing is meaningful and impacting your work. So this has happened in a short amount of time, but we've also accumulated a great amount of experience. A lot of lessons have been learned, and a lot of what we're going to talk about is sort of recapping those 2 years, telling you what are the things that we're improving, telling you what are the things that are new because of everything that we've done so far. So to start, I'm going to talk about one of the most prominent projects we have so far, which is Next.js. Next.js has started as the easiest way to build React applications. So we saw that the React component model was incredibly powerful, but it was kind of hard to get started. It was hard to just put a few pages together like you would with, let's say, a PHP project. And at the same time, we saw this incredible opportunity to enable things that weren't so easy before with JavaScript applications, such as server rendering or pre-rendering of client-side applications. So we decided to go ahead and create this single command utility called Next to bootstrap this sort of project. So many of you have probably already seen this video, but it's worth showing it again, perhaps even more so because we have maintained really good backwards compatibility, which I'm very happy about. So the gist is you have a pages directory, and inside you define the files that become the entry points to your application. The only contract that we expect is that you export a function or a component that describes your page. So as you're going to see on the left-hand side, everything that happens via hot module replacement. So as I'm making changes to my application, everything reflects in real time, even creating new pages. So I see a 404 there, and as I create a page, it is going to populate as soon as I save it on the right-hand side. What's very interesting as well is we've made it so that this idea of dual rendering is very prominent. You can do things on the server, and you can do things on the client, which has made us focus a lot on this idea of pre-rendering, which gives you a lot of really interesting performance optimizations for your projects. This example focuses on this idea of the lifecycle hooks activate on the client and some pipelines activate on the server, for example, when I do a hard refresh of that window. I want to go into some numbers of the project that I think are truly interesting. So first of all, we're one of the most followed and favorited frameworks so far. We have over 400 contributors that have landed PRs or made the framework better in some way. We've made over 170 releases. We've closed countless of pull requests. We've received a lot of forks. And what's perhaps really interesting is we set out to try to measure the success of the framework in terms of real-world usage. So what we found by crawling the entire web is that already 9,200, almost 10,000 domain names are serving content generated by Next.js, all the way from Alexa top 25, I believe, to some of the darkest corners of the internet. And there is a great Vue.js alternative, Next. Very important data point. So Next.js has continued to evolve in a very remarkable way. And today we're introducing Next.js 6, which has very exciting new improvements. So I'm going to hand off to Tim Neutkens, the lead core developer of Next.js, who's going to tell you all about it. Thank you.
Hi. So yeah, I'm going to talk about Next 6, which is the latest release. It's coming out later today or early next week. We focused on providing a smaller core, which introduces fewer modules into your application with less dependencies. This also has a side effect that makes the boot up time very much faster, which allows for a feature that we're introducing later today to be way faster. We've also introduced faster server rendering page lookup. If you follow the releases in Next 5.1, we also improved the page lookup, but now it's like 100 times faster again. We've increased reliability. We've done it in a few ways. We've added more integration tests. Hot module reloading is now tested. You can also, we've also added security tests, which basically everyone that actually send a security vulnerability, we've added a test so we never regress on it again. We've introduced flow types and stronger coding conventions. And now I'm introducing a new feature of Next, which is the pages/_app.js. This basically wraps all pages on the client side, on the server side. Compared to _document, if you used Next before, it is basically meant to augment the HTML that's output on the server side. But _app allows you to augment the client side too. So you can wrap layouts, implement, get initial props in it, and then use Apollo or Redux. Way easier, because you don't have to wrap the pages anymore. So the use cases for this, like I said, are page transitions. So we've had someone from the community who actually created an example of page transitions going like this. So basically, it's just a Next.js website. It does everything like usual. You can click the links, you can open any page, go back, and it will just transition all the time for when it's needed. Also, like I said, better Apollo and Redux integration. We've introduced error boundary handling. So React has this thing called component.catch, which catches all errors. But it wasn't exposed to the user, so we implemented it and you couldn't extend. Now you can extend it and implement your own error handling logic. We've improved static export support, which means before you had an export pub map, which is basically a mapping of every file going into, when building the static website, it would take this map, and it would take all the pages and then map them against them. Now you don't need it anymore. You can just create a static website with 0 config, which is basically, you can also just run next export without the export pub map. So you run next build and next export, and that's it, nothing else. We're also introducing something new today, which is seamless markdown support. It's not a core feature of Next. You can use it with any type of application that supports React. but it's called MDX, which is Markdown with JSX in it. This allows you to write blog posts or documentation without needing to write a lot of HTML inside of JSX, but you can just write Markdown and then import dynamic components inside of your Markdown. It looks like this. So you import a graph. This graph is then used inside of Markdown. This allows you to write blog posts very quickly because you don't have any bloat from the HTML tags. It's 100% pluggable, agnostic, and composable. This means that you can write plugins that augment the MDX behavior. So you can write a plugin to do title capitalization based on your own rules. At ZEIT we have title.sh, maybe you've heard of it. It's basically a website you can go to and paste in any text or any title, and will turn everything in the right capitalization. And now we have an MDX plugin for it, which automatically does this, which saves time. It's available on GitHub already. It's a stable release. We use it in production. You can use it also. It's on the MDX.js repository, basically MDX.js/MDX. You can use it in production right now. Then we introduced Babel 7 support, which introduces JSX fragment syntax, which looks like this. You can write empty JSX tags and it just works. You no longer need extra div. It has first-class TypeScript support, which is also pretty nice because you never need a loader again just to write TypeScript. There's per directory Babel RC, which means that you can actually apply specific Babel plugins just to specific directories. Say your components need some transformation that the other pages don't need. You can actually save a lot of time by applying this. So Next.js so far has been README-driven development. What we mean by this is that we actually just write the specification of what we're going to do first in the README, and then we implement it. So actually the first commit on Next was a README file. It didn't have anything in it. And a few weeks later, Naoki Kanazawa, he actually implemented whole of Next.js. And what's also really good to note is that this part of the README is actually still the same. There's nothing changed, only grammar or other stuff. So it serves really well, README-driven development. But there are the side effects that when you start developing on Canary branches, and everyone goes to the README on GitHub, you actually see the new features before they are released. So people are basically asking, hey, can I use this feature? It doesn't work, but it was just not released yet. So we have something new for you, which is, and something better, it's nextjs.org. It's a new website. It has the documentation, learnnextjs.com, and a lot of new things. And I'm going to invite Jimmy Moon, who is a core contributor to Next, to talk about it here.
Thank you. Hi, I'm Jimmy Moon. I'm so excited to introduce a brand new website for Next.js. As a big fan of Next.js and ZEIT, I've been using Next.js for a long time. And GDE, Google Developer Expert, I have advocated about the Progress Web App in Korea. So I also made a couple of plugins for Next.js and for Progress Web App, Workbox and Manifest. So I believe that the Next.js is one of the best way to build progress web app in mobile era. So let me show some video. To prove it, I made this video. This video shows how to get started progress web app with Next.js. As a sample is HNPWA, is Hacker News for progress web app. It's very stereotype progress web app, promoted Eddie Asamani from Google. And then I want to show this video is how fast we can build progress web app in minutes. I made this video is from scratch with Next.js. So added more styles, added more features, passed the data from HMPWA APIs. So I think it's the best practice for you. And we all put together this related to Next.js. Docs, and you can learn more about the Next.js. And only for learning how to make new things, we would like to give inspirations. So it's showcases. In the showcases, we're gathering our most interesting website built Next.js. You can check out this route right now. It's a beautiful site. So go make it and share to us. Thank you.
So that's pretty incredible. It's been fascinating to see Next.js just make its way everywhere. So I'm very thankful to Jimmy that he's been helping the project so much in a remote way. He came all the way from South Korea to present this amazing work that he's done. So feel free to head to nextjs.org to get any inspiration that you need from others, as well as also taking advantage of learnnextjs.com, which used to be the go-to for getting started with the framework, has now been merged onto our main website. So thank you also to Arunoda, who couldn't make it, unfortunately, due to visa issues, but I'm sure he's tuned into the live stream, and he's very happy that we've found a new place for learnnextjs.com. So the next thing, no pun intended, is talking about how to bring these creations to the cloud instantly. How to do so in a scalable way, how to do so in a predictable way. We want to talk about this idea of serverless deployments, but also providing some context for how we think about it. So again, if you're not familiar with Now, it's a single command solution for bringing any deployment of any type, static or dynamic, to the cloud. We've recently introduced global support, which means your deployments go to the nearest data center automatically. So in this example, I'm deploying WordPress using a Docker file. And all it took is for me to declare the code of the things that I added on top of WordPress and my Docker file. So you can see there I have my themes and my plugins, etc. So in order to give you an idea of how massive Now has become, we introduced it 2 years ago. There's over 100,000 developers signed up on the platform. Over 1 million deployments have been made by these developers. Collectively, as you've seen in that video earlier, the first step is to upload your assets and source files. Collectively, they have uploaded over 120 million files. And as you saw, you get sort of a temporary URL. We call it an immutable deployment that you can later on assign to a custom domain name, of which we have over 40,000 currently. Over the past few months alone, people have downloaded our Now CLI utility over 200,000 times, which we tend to update quite a bit. And very interestingly, we've just found out by crunching some numbers, as of today, 4 out of 5 deployments are made by paid customers. So we have a very powerful free tier, but we're also very happy to see that people are continuing their journey within our platform. So I'm very thankful for that. And as I mentioned, we now have a data center live in California and one in Brussels in Europe. I wanted to provide context of what serverless means to us because I think, for the most part, there's been a lot of confusion over what this term in particular means. One of the ideas that we always take as a priority is this idea that you have to focus on the code, not the infrastructure. So the example earlier made that very clear in that you only wrote the necessary bits of code within a framework, within a programming language to make a deployment to the cloud. You can think of making a URL as a function of your code. In fact, if you don't change your code, we give you back the same URL so that you can continue to reuse the same build images that you've made in the past. So part of that experiment showed there was no Docker container, there was no Docker in the client even, there were no VMs, there was no container management, there was no manual anything. The second part that's very critical is to make a deployment self-healing. So what we think about when we talk about self-healing, we think, first of all, the developer shouldn't have to worry that everything has to go perfect all the time. We must account for errors, either in code or errors that are happening because of programming mistakes that accumulate slowly over time until disaster occurs. We want to prevent the developer from having to consider all possible bad scenarios that their code and state can fall into and make it so that their code is automatically self-healing. The way to illustrate this the best is avoiding the situation of getting paged to manually restart a service. That's what I think the serverless paradigm fixes once and for all, perhaps. Tied very closely into this is this idea that things have to scale elastically and automatically. In particular, one of the very critical insights is that, if possible, code should not run if it's not doing any meaningful computation. So what happens a lot of times when we deploy web servers or APIs or microservices is they just sit there. And we have a unique advantage with now in that we give you a URL to your web service or website, which means we can sort of make management of traffic the same pattern as management of the scale of your microservice or website. Which means if a request comes in and your code is not booted up at that point, we need to make it boot up automatically and instantly. And the scalability model that follows has to be very predictable. It doesn't have to involve very complex statistics or charts that are hard to understand or wrap your mind around. You have to have a very simple model in your mind for how the service is going to replicate itself in order to scale. And a very important part of that is not relying on partial information or human-driven heuristics too much. An example of that is a developer notices that there's an outage or elevated response times and proceeds to come up with a magical number of copies that their deployment should be running in order to satisfy the incoming traffic. The next step is to mark the issue as resolved and perhaps forget it upscaled to 1 million copies and just leave it there, burning the universe away. So we've taken a good look at these 3 principles, and we've completely revamped our infrastructure. So we first took a look at what makes a deployment fast. We experimented with a lot of things. At some point, we experimented with running just binaries, just ELF Linux binaries. Later on throughout this journey, we found that we could make Docker deployments even faster than just spinning up a new process. The techniques that we've applied and the research that we've done have concluded that we can make Docker truly serverless. So for that, I'm going to invite onto the stage our chief scientist, Josh Junon.
So what makes Docker files super, super great for deploying applications to the cloud? Well, first of all, Docker files don't care at all about the technology, the language, or really the application that you're creating. They care about making sure that all of your builds, all of your runtimes, all of your tests, everything that you're doing are standardized and reproducible locally as well as remotely. We've kind of taken the Dockerfile approach to deploying applications a little bit further. And we've added certain knobs and levers to allow you to change how you want your application to scale, when you want it to sleep, things like that. And the biggest thing that we wanted to capitalize on in the next step of our cloud is, if you have an existing application, it should not be super hard to convert it to a Docker file. So let's take a Node.js microservice, and we're going to deploy it here. And as you can see, it's exactly the same as you do now. You run now. Our microservice is just running micro. It just is a simple API. It exposes a simple API endpoint and returns a JSON object. And as you can see here, a little bit has changed in the terminal. So you can see the standard Docker build process, and then we also show that we're assembling the image, and we also output the image size. And I'll talk about that a little bit in detail here. I'm also showing you a little bit of the code. What's interesting here to see is that our builds are going to get much faster, and we're going to talk about that a little bit as well. So in this particular microservice, we have a Docker file that just pulls in just a basic Node.js base image. And then we have a very simple index.json, or .js, excuse me, that exports our application's code. I'll take a look really quick. So we see success, deployment ready, and then a very simple file system in our microservice here. So let's go ahead and run it. Now, running it now on the existing platform means scaling it up to 1, or having a request unfreeze it. So as you're seeing here, these are our new times. So we're seeing time curl, and then our new deployment's URL, and our first deployment, our first run, never been touched by our servers. The image has never been pulled. It has never been unfrozen before. None of the caches are warm. It unfroze in a whopping 616 milliseconds. Yes, thought you'd like that. And as you're watching this a little bit further, you can see that subsequent requests use pre-warmed caches. Depending on your concurrency, your max concurrent requests, it might reuse an existing running deployment. And so you can see we run it 3 times here. The first one's 616 milliseconds, which is leagues faster. And then subsequent ones go down to just over 100 milliseconds. So again, the first request, if your max concurrent requests or things like that, your scaling constraints, if the request would exceed those, we'll scale up for you. And scaling up when we already have our caches warm is extremely fast. In fact, right now we're seeing measurements of just simple Node.js deployments unfreezing 10 times faster than what we've been seeing in the past. And even on bigger images that we're seeing, bigger Docker deployments, more complex applications have much bigger image sizes and much more complex machinery involved, we're seeing even 20, 30, or 40 times faster unfreezing upon a request, which is a massive improvement to the current state of affairs. So let's look at the now. Yeah, this is great, by the way. This is a lot of work. We thought you'd be excited about that. So let's look at the now.json configuration file for that particular deployment we just made. So as you can see, we have a new top-level property called limits. And in limits is an object that specifies a few things about the application that we want to create. This is completely supplied by you as the developer. So the first one we're going to look at is max concurrent requests, or max concurrent recs. In this particular case, we set it to 1. This means, at most, we only want 1 concurrent request to deployment at a specific time. If another request comes in while an active request is hitting an instance of your application, we'll scale the application up again and unfreeze it again in that very small amount of time. The next one is timeout. So timeout is the time between a completed request, or all completed requests in an instance, to the next request that may or may not come in before we shut down that instance. And so if you have an application that's spun up once, maybe every 20 minutes, and you only want it running for the duration of maybe 1 or 2 minutes, the rest of those 18 minutes, you're not paying for. So that's a huge improvement in terms of specifying exactly how your application should run and how you want it to run and scale. And the last one is kind of complementary as well. It's maximum duration. So even if you're getting a lot of requests in, it's not exceeding that timeout period. We can actually wait and drain your application's requests after a certain amount of time, in this case 5 minutes. So after 5 minutes, we'll wait for all existing pending requests to complete, and then we'll shut down the instance. And this helps keep things a little bit more robust. We know that big applications or even small applications can become unstable over a certain amount of time, and so this kind of helps keep the robustness and helps your application self-heal if it becomes unstable over time. So to recap, we defined our own specific Node.js version as well as how we wanted it built. I like Yarn, you might like NPM, and you can specify that now. It's completely up to you, and you can specify that in the Docker file, and we don't care. We don't interfere with that at all. We also didn't rewrite our code. This could have been in a completely existing or a completely written, completely finished microservice that we just adapted to be Dockerfile driven or described by Dockerfile and now.json and deployed to our platform. And we reused the HTTP protocol, which everybody's familiar with. Nothing has changed there. And then finally, we added on those scaling rules. We specified exactly how we want our application to scale when there's too many requests coming in, or maybe it's seeing a spike in load or something like that. Maybe you're having a holiday or some sort of sale or something. You can scale accordingly, very specifically and explicitly in your now.json. We described how we wanted it to heal, if we wanted it to die after 5 minutes because, I don't know, maybe we're testing something new, or we described how we want the lack of requests to affect the current scale of your application. So this microservice was completely stateless, and based on HTTP requests coming in, similar to how we have it now. And the interesting thing about this is that if your max concurrent requests is more than one, then you can reuse an existing deployment. But if you don't want that, if you want to set max your current concurrent requests to a maximum of 1, you can have a new instance of your application for every single request that comes in very, very small amount of time. Remember that 100 or 120 millisecond average for that node microservice. So let's look at another example. Go and WebSockets have been a major player coming into the industry in the last couple of years. And so we're going to play with an example there. Here we're going to deploy a single line Docker file, that's it, from Go TTY, which just spawns up a terminal in the browser. Now the interesting thing about this terminal, it's a full TTY session that uses WebSockets to connect to the server. And the server is running in the container. It's not emulated, it is using the real file system of the container itself. So same thing here, we see a build, we see the assembling the image, we see we're storing the image, it's 6.1 megabytes, and then finally it says that we're ready and we're good to go. So the interesting about this is we're going to keep that max concurrent request set to 1. And what that's going to do is we're going to see a brand new terminal for each tab that we open. And as you see, as we're opening up these new tabs, a new computer, basically, a new TTY session for a brand new container is being created. This is not sped up, just to be completely clear. This is real time, this is real, it's not fabricated, this is real live, a real live deployment. And so we're gonna open up 5 tabs here. And each tab we're gonna touch 1.txt, 2.txt, 3, 4, 5. And you can see as we ls this directory, they're not there between the different tabs. We have a maximum concurrent request of 1. So once we close one and that slot becomes available, the request is ended, we can go back and reuse it again. And you can see us reopening some of these tabs and seeing some of the old files there. And that's showing and demonstrating kind of how the max concurrent requests limitation works or constraint works. It was very interesting stuff here. So on top of that, we're also introducing a way to customize how you want to, or how much memory you want to use, how many CPU, or how much CPU power you want. all of these resource allocations, we're giving you the power to do that now. So for this example, let's mine some Bitcoin. Now I have to disclaim that we obviously don't allow Bitcoin miners. We get yelled at by several people. But just for the sake of today, we're gonna do 2 Bitcoin miners. And for this particular demo, we've allocated 4 CPUs per miner. So that means when an instance of your application boots up, it'll be allotted 4 distinct CPUs that it can use for multi-threading and all of that stuff. So let's visit the Bitcoin miner. So as you can see here in the web interface, we have our hash rate and current nodes. And as we open up the second one, we have a max concurrency of 1. And so we'll see this connecting to the slush pool, and it'll populate. So now we see 2 nodes, and we're going to see our hash rate increase shortly. There we go. And these are fully functional. As tested, we're using the standard Bitcoin miner with just a small microservice to expose this interface. So fewer copies of your code means you can run more stuff at a time. The goal of a lot of this was to be able to limit how much your code is actually running in production. It cuts down costs on you, and it helps us help you a little bit more. And so with that, we're currently there. We're gonna be rolling this out in the coming weeks. A few customers have already seen this new functionality, but the biggest thing to take away from this is fully backwards compatible. All existing Docker deployments are going to work just fine on this new platform. All node deployments that you want to move to Docker files should be very simple, and you shouldn't have to rewrite your code at all. It's 100% backwards compatible. It's a complete platform upgrade. And so something else to note about this, in order to help us help you, and to help facilitate us unfreezing your application quickly, it is important to note that your build image size is directly correlated to how fast we can unfreeze it. Basically, when we unfreeze it, we have to pull your application to somewhere if it's not already pulled. And the smaller your application, the faster we can do that. And so to help facilitate that, we're introducing some tools to help you manage your build image sizes and introduce a new build pipeline that kind of comes with that. And to talk a little bit more about that, I'm going to introduce Mateus Fernandez and have him come up onto the stage. So thank you so much. Thanks.
Hi, everyone. So as Josh just said, the smaller your application is, the faster it's going to run, right? The faster it's going to be downloaded by our machines, and the faster it's going to be executed. So to take, for us to enable you to take the biggest advantage of everything that Josh just explained to you, of all those amazing unfreeze times, of all of those new configuration options that you have on now.json, we are introducing a brand new build infrastructure, a completely revamped build pipeline. So we have made significant improvements to help you. So we have made significant improvements to help you build faster and more reliable applications. What does that mean? That means that we're gonna enable you to we're gonna provide you more tools to take the best of our platform, to take the best advantage of our platform. So one of the things that are important to achieve fast unfreeze is that we have to be able to download and compress and uncompress your image very quickly. We have to be able to uncompress your application as quickly as possible. So to achieve that, we have chosen a high-performance compression algorithm, and we also are now showing you the build size, the image size of your application as soon as the build step is complete. So you can know how much we are going to have to download for your application and how much you're going to have to uncompress to run your application. Regardless of the image size, if it's big, if it's not big, we have to be able to download it very quick. It needs to, when your deployment is assigned to a machine, we have to be able to download it immediately. It has to become very quick. So to achieve that, we have designed an IPFS-inspired peer-to-peer network for fast intra-cluster image distribution. So what does that mean? How can we illustrate that? So let's imagine that we have a data center with 4 machines, each of the big blue boxes, across, let's say, 4 availability zones. And let's say that your deployment is assigned to a slot inside of one of those machines, like the slot in red there. Let's say your deployment is assigned to there. And that machine, it doesn't have your image. The image is not on the local disk. So today, what we do is we go to Amazon S3 or Google Cloud Storage, we go to a third-party storage solution and download your image. The problem with that is that can be very far away. It can be on cold storage. For example, if your deployment was less than freezed 6 months ago, it's gonna take a while to fetch that image. It's gonna take a few seconds. So what we have done is, it's very likely that another machine in that same data center already has your machine, already has your image. Because your deployment was run there previously. As Josh showed you, we run our deployment many times, depending on your configuration. Each request is a new copy. So it's very likely that your deployment was already run in that data center. So what we do is we transfer the image from a very close-by machine. So we go from the square in green, it goes directly to where your deployment was assigned at this time. So what does all this mean? It means that we can fetch your deployment as quickly as possible. It's like if you were transferring a file in your Wi-Fi in your house, but even more performance because our data centers have enhanced network capabilities. And to help you also take advantage of those very fast download speeds, and to help you produce small images, we're now introducing multi-stage Docker builds. What are multi-stage Docker builds? So you can do on your Docker file, let's say that you have a stage that builds your application, it builds a binary your code. So you can reference it, like from X as build, you can reference your build artifact as one stage. And then let's say you also have tests. So you also reference your tests from another image, right? And that's new. That's what important here. From scratch, what does scratch mean? It's the tiniest and leanest Linux image available. It's a very small image. It doesn't have any overhead, doesn't have any binaries, anything. And then you can copy from the first step, from the build step, only the binary with your code. You only copy exactly the piece of code that is going to be executed when somebody hits your deployment. So as a quick recap, what does that mean? It means that with Docker multi-stage builds, you're going to be able to create the smallest image possible. For example, you can have a huge build step, like a lot of dependencies, a lot of node modules, whatever you want, like a lot of C dependencies or whatever. But it doesn't matter, because if you go back here, you only copy the binary from the build step. You don't copy dev dependencies or not even production dependencies. You can link all of the with PKG, which is a project we have, you can insert all your dependencies inside the binary. So you only copy the binary for the resulting image. And that also means that you can run steps as part of your deployments. You don't need to have a dedicated test infrastructure, like a dedicated Jenkins infrastructure. You can run the tests in the deployment, but then you only copy the binary. You don't need to copy test code into the production artifact. And to show an example of how Docker multi-stage builds can help you, I'm going to show you a few numbers for our biggest and most important Next.js frontend, which is ZEIT.co. So with the current infrastructure, with the current image, we have a resulting artifact of 131 megabytes, right? With the new multi-stage builds, and plus PKG, which is a Node.js compiler that we announced last year here in San Francisco, we have now a build image, an image of 82 megabytes, which is more or less 40% smaller. So that means, for example, that we can now unfreeze your deployment 2 times faster. Thank you. On top of that, we are also deploying a lot of measures to ensure that the layers that your team are using are more likely to be cached. What does that mean? When your build is scheduled to a machine, now it's way more likely that a previous build of your same deployment from your same team was also run on that machine. So it's very likely, for example, that the front build or the front steps or like the node modules or something like that, it's gonna already be on the same computer. So there's not even need to go to a neighbor computer to download like node modules or anything. It's more likely that it's gonna be in the same machine, the same computer. And to illustrate even further, I'm gonna show you I'm gonna show you the difference between our current build infrastructure and our new build infrastructure. Again, for ZEIT.co, like the build times for ZEIT.co. So before, like today, ZEIT.co takes, the mean build time for ZEIT.co is 4 minutes and 17 seconds, and a 99 percentile of 11 minutes and 56 seconds. So every other time you deploy, it takes like 3 times or 2.5 times what it usually takes. With our new build infrastructure, your deployments are going to be more or less half of the time. And if you look at the percentile, it is very consistent. You can rely on the build. It's not like every other build is going to take 11 minutes. They are always more consistent. They're more reliable. So yeah, you have fewer layers, large contention with better resource allocation, which means you can rely more on the builds. It's not like every other build is going to take 11 minutes or 12 minutes. And to show you, to help you understand exactly what is going on in the build phase, for you to be able to see exactly what your image is going to be, we are now on the CLI making a clear distinction between the build logs and the runtime logs, the instance logs. So if you look there, it gives you the URL and it says building, and those are the logs for the build step, for the build phase. And then later on, when we instantiate your application, when we run your application to verify that it works, to verify that it can start, you can see that there's a very clear distinction between the logs for the build step and the instance logs. Like the instance log is even prefixed by the index of the instance. For example, let's say you want 5 instances, so it's going to be, you're going to see 0, then 1, like you're going to see 5 copies of the logs. So you can always have a very clear notion of what is going on your build step, on what your image is, what is happening to produce that image that your deployment has. And we also have one more thing. So all this faster stuff, like this faster unfreeze, like a 100 millisecond unfreeze, 2 times faster build, it basically means that you're going to pay less money to us. You're going to spend less. Because if your build is taking half of the time your code is taking half of the time to be built, that means that your code is gonna run obviously for half of the time. So you pay half of the money. You're not paying 4 minutes anymore. You're paying 2 minutes. It's not like every other time you pay a lot for the build because the build was lower because it was an outlier. You're always gonna pay less. Also, same for unfreeze. Your code unfreezes faster. It starts faster, so you pay less. And to help you visualize all that, the reduced spending, everything that you're using, what is going on with your billing, I'm going to invite to stage Leo Lamprecht, our VP of Product, to talk more about that to you. Thank you very much. Thanks.
So, thank you, Matthias. As we talked about, as Josh and Guillermo and Matthias talked about earlier, we have a lot of exciting stuff for you in the coming weeks. We'll be rolling it out next week and the following week after that. One of them is Slots, for example, which allows for apps to freeze and unfreeze extremely quickly. And just like Matthias said, this will also influence how we charge you for the deployments you created. Because Slots, for example, are capable of, in technical terms, freezing and unfreezing within about 30 milliseconds, not seconds, milliseconds. So that means if you're only getting a few hundred requests per day, or maybe even only per week, we will only charge you for those that are coming in groups, basically, and unfreezing a deployment. And to help visualizing this, we built something that we call the usage reports page. This page will basically be containing the usage information about how much storage you used, how many instances. It depends on what plan you're on. The information will change depending on the plan you're on. And for example, here on the Hyper team, you also see our past invoices and also the upcoming invoice. We partnered with our friends at Stripe to also allow you to download the invoice directly in the past invoices group down below. This will allow you to, before you even get the bill, see what you'll be charged. And then, as you might have already noticed, we announced something a few weeks ago, which we call add-ons. Currently, we provide add-ons for priority support, advanced support, and live support. Those basically allow you to, if you don't want to wait for us to respond, opt into something that allows you to directly interact with us using email with a fast response time, or Slack even if you want. So to make this even better, this whole add-on setup, we are now introducing something called custom team deployment suffix, which is something especially companies will be interested in. And this is how it works. You basically, as you probably have already noticed, end up with a now.sh domain, subdomain, every time you create a deployment. Deployments are immutable, so you get a new URL each time. And thanks to this add-on, you'll be able to change this suffix. So no matter what domain you want there, you just enter it after you enable the add-on, and then the CLI, now desktop, all other clients that we might introduce in the future will automatically deploy under that domain. This will not only give you like a sense of privacy, but it will also allow us to, in the future, introduce more features to kind of shard these deployments from others by providing more security features. So this is an example for creating a deployment in our CLI that has such a custom suffix. And as you can see, the deployment URL ends with site.sh. The reason why we're showing .sh here is because we're going to announce this week, when this is going out, that every customer that has a paid plan will receive an email saying that you'll be able to enable this add-on and get a .sh domain for free forever, not just for 1 year. This will allow pretty much all of you to easily have such a custom domain for your team. So that's what I just said. You'll get the free SH domain, like I said, not just for 1 year, but forever. And yeah, that's the great thing about add-ons. Now I'm going to invite Gisham Rauch back on stage to share some final thoughts with you.
Thank you so much, Leo. So to recap, today has been a really exciting day of announcements. We took a look back at everything we've done so far, and we decided to make it, in some cases, 10 times better, 50 times better. A lot of what we introduced today is not necessarily new features or breaking changes. It's all about the opposite. We found a great model of computation that we wanted to continue to explore very deeply. And we're not even done yet. I think one of the impressive examples was unfreezing a deployment in 600 milliseconds, which would normally take like 6-10 seconds. And due to some of the existing technological pipelines, that was sort of the de facto answer for accomplishing that. We found that by continuing to focus on open standards and trying to target the deployment manifests and ways of defining your infrastructure that already exist will make a future-proof way of putting your applications online, putting your ideas online, without having to reinvent the wheel every time. So we're excited about continuing to do the same. So for the rest of the year, we're going to continue to unveil improvements to these existing new models and pipelines that we've introduced, just making them faster, more efficient, more scalable, and in some cases, more accessible, perhaps behind private networks. In certain circumstances where you haven't been able to put now yet, you will be able to. So I want to thank you all for taking part of this very special keynote. And I invite you to stay engaged for the amazing lineup of speakers we have for the rest of the day, which some come with very, very, very exciting announcements as well. So thanks a lot, and we'll see you later today. Thank you.